So in our homework, question number 47 is asking us to find the interval over which the function's curve is increasing. It's a shame that they give us e to the x again. I'm not sure why this guy is so into this natural number, but anyway, we can still derive the interval from it. So the first thing, obviously, is we need to find the derivative. So let's take that, and I'm just going to use f prime of x. And we are going to take the derivative with respect to x of this function. So let's just look at it. Rather than splitting it up, we're just going to look at this and say, well, what is the derivative with respect to x of 5x to the first power? Well, we'll bring the 1 down. 1 times 5 is 5. X to the first minus 1 is 0. X to the 0 is just going to be 1. So we have 5 minus, and we have found that e to the x, the derivative of that is simply e to the x. So that's an important one to remember because apparently that keeps coming up. All right, so now we have our derivative function. What do we do now? So in order for us to find out where along this function's curve it is increasing, we need to find out at what point on that function's curve is there a horizontal tangent. So if I have some curve, we know that at the point where it is changing position from positive, or increasing in this case, to decreasing, there's going to be an exact point at which we can say there is 0 change in position. We would also call that, or we've been learning how to find the horizontal tangent to that position of the curve, or to that point of the curve. We would have another one here as well, where it is changing position again. So in order for us to find that change in position, we're essentially asking at what point on this function's curve is there a 0 slope, no slope, 0, no change. In order to do that, we need to set this derivative equal to 0 change, or simply 0. So we take 5 minus e to the x is equal to 0. Now we want to solve for x, and it would have been a little easier had this not been e to the x, but we can still do this. So we will subtract 5 from both sides. That's going to leave us with negative e to the x is equal to negative 5. We will then divide both sides by negative 1. That is going to leave us with e to the x is equal to positive 5. So at this point, we need to recall from pre-calc that anytime that we have an exponent, a variable exponent, that we can use logarithmic to set each side equal. So we set the bases equal. And in the notes, I do explain that essentially, if you have ln of e, that would be the equivalent of writing it as a log base e to e, and that would be the equivalent of simply 1. So let's do that to this equation here. So we are equality now, and we're essentially going to set this equal to ln of e to the x is equal to, and the other side we have to do the same thing, ln of 5. And what this allows us to do is essentially bring the x down. We now have x is equal to ln of 5. And of course, ln of 5 doesn't tell us a whole lot, but if you put that in a calculator, and I'll put this in the top left, ln of 5 is approximately equal to 1.609, and on and on. So now that we have found the only point at which this function's curve has zero change, or as we've been calling it, a horizontal tangent, so we have the point x, it would be good to find the actual point, which includes x and y. And in order to do that, we take ln of 5 and we plug it into the original function. So we would have f of ln at 5 is equal to 5 multiplied by ln of 5 minus e to the ln of 5. And this gives us an approximate value of 3.047. So now we do have the point at which this function has a horizontal tangent, and that point is ln of 5, and the y value is roughly 3.047. So now that we have that information, we still have not determined where this function is increasing. In order to do that, we can use what in statistics they call a sign test, and in calculus it's actually known as the first derivative test, which makes sense because we are essentially using derivatives to find slope, and the derivative function can tell us where something is increasing or decreasing. So I am going to draw a line. I am going to mark the middle as ln of 5 as the x point. We'll call this an x. And essentially what I want to do is find out what's going on to the left side of that value and what's going on to the right side of the value. And the best way to do that is to take this function, the derivative function, which is really the first derivative function that we found, and we're going to just plug some values in. But not just any value. We want to plug in a value that is just a little less and a little greater than ln of 5. And again, we said that ln of 5 is roughly equal to 1.609. So let's finish our function. We have 5 minus e to the x. So if I plug in a value that's just a little less than 1.609, and we plug that into our function, well, the easiest value is 1. So if I plug in a 1, I will end up with 5 minus, and I also put what the value of e is approximately, which is 5 minus 2.71828 to the first power. As you can see, 5 is greater than 2. Therefore, this is going to be a positive outcome. Whatever the solution is, I'm not even concerned with an exact amount. I just want to know what is the solution's sign. And in this case, it's going to be positive. So it'll be positive at 1. So wherever 1 is, and say 1's here, we know that it's positive. And if I chose another number that is just a little bit less than 1.609, so let's just say 1.6. Well, 5 is still going to be greater than e to the 1.6. So it is still positive on the left side. So we do the same thing to the right side. So if we choose a value a little bit larger, so let's just say we choose 2, what we find out is that now e squared is going to be a larger value than 5, and our solution is going to be negative on the right side. In fact, no matter what value, just larger than ln of 5, I choose, it is going to have a negative value. Therefore, on the right side, all values to the right are negative. And now let's put the pieces together and figure out what we're talking about. So if I know that when I plugged in values into my derivative function, I got a positive value on the left side, well, the derivative tells us the change in position. It also tells us, if it's positive, that it must be increasing on the left side of ln of 5. Therefore, if we see negative solutions on the right side of ln of 5, it must be decreasing. This question only asked us on what interval is the function increasing? Well, there's some things that we found. We found that there's only one point which this function has a horizontal tangent. We found that it is the point ln of 5, 3.047 for x and y. So that's the only point at which this function is changing. We should also know that because this is somewhat of a polynomial, we can say that it is increasing from a negative infinity, essentially to the left of ln of 5 forever. This graph will continue on and on and on. So to create an interval that is increasing, we can say that it is increasing from negative infinity up to, but not including, ln of 5. And that is your solution. So I hope that helped, and thanks for watching.